So we're going to start talking about the unit circle. And I know you've seen that before, but we're going to do it from the beginning. Okay? So if you have any point in space, like here, we'll call that point P, right? If you were to draw a ray from the origin to that point, right? That's what that would look like. In math, a ray directed from the origin to a point in space, we call it a radius, right? And we give it the symbol R. That's what it looks like. Now, when I draw that, I automatically create an angle with the x-axis. Okay. Now, there are a couple of ways for me to go to that point. One is I could just walk along that the radius, or I could go over horizontally a little bit and then vertically a little bit. Okay? If the coordinates of that point P are x comma y, okay, how much am I going to walk horizontally? How many units? How much? X units. And how many units am I going to walk up vertically? Y units. Okay. And now, because the X and Y are horizontal and vertical, what kind of angle do they create in the middle? 90 degrees. And now automatically you've got a right triangle. And when we've got a right triangle with an acute angle theta, we can find the sine of theta, right? Yes? What is sine of theta in that colorful little triangle over there? What is the sine of theta? What is it? Y over R, right? The sine of theta is y over R. What about the cosine of theta? It's x over R. And what about the tangent of theta? Y over x, right? Y over x. Okay. So the sine over here, sine of theta, is y over r. And is y the vertical or the horizontal? The vertical over r. Okay? So sine is the vertical side over the radius. Okay, good. Take a look at this angle here. Okay, let me make this angle theta. Because in trig, when we draw an angle theta, it's always between the x-axis and the terminal side, always. So now if I have this and this, if I have this triangle here, right? Okay. And again, if I have to go over x units, and if I have to go down y units, and that's r, if I wanted to find the sine of theta, what is it? Sine of theta. Y over r. So again, sine of theta is the vertical over the radius, right? What about the cosine? The horizontal over the radius. What about the cosine here? The horizontal over the radius, right? So let's remember that sine always takes the vertical side. Cosine of theta is x over r. That's always going to be the horizontal side. And with that, we could do cosecant and secant and all that good stuff. Okay, fine. So now we've been talking about r, fine. If I know how much x is, suppose x is equal to, 4, and suppose y is equal to 5. Is there a way for me to find what r is? Pythagorean theorem, right? So here I can find r using this. And so now, suppose instead of the point x and y, suppose we actually have coordinates for that point. Suppose the coordinates for that point is -4, 3. Can we find the other 6 trig functions of theta? Well, let's see. I'm gonna draw a diagram once. -4, 3. Here's where P is. And theta always goes in between the x-axis and the terminal side. And so now here I have a little triangle. Okay? So how much is R in this case? This is R. How much is R in this case? What are the sides of this triangle? 4 and 3, 5, right? That's a 3, 4, 5 triangle. If you don't believe me, you could do a squared plus b squared equals c squared, right? Okay. So now, what is sine of theta? Well, sine of theta, we said sine was always the vertical. So take a look at the vertical distance here. It's a 3, right? So it's going to be 3 over 5. Right. Okay? Cosine of theta, cosine we said was always going to be the horizontal. The horizontal distance over there is how much? 4, except it's in the negative direction. So it's -4 over 5. And tangent is always going to be the vertical over the horizontal. So 3 over -4. And from that, can we figure out cosecant, secant, and cotangent? It's just the reciprocals. Yes. Okay. All right, now, what if my point wasn't -4, 3? What if my point was -4, 0? Where would it be? On the x-axis, right? Okay, so let's take a look at that case. What is those? Yeah. If it was like -4, 0, then it would be on one of the axes, right? So when the terminal side lies on one of the axes, we say that angle is a quadrantal angle, okay? So for example, suppose my coordinate is 1, 0. It would be right there, right? It would be right there, 1, 0. How much would the radius be? 1, right? 1. If the point was at, I don't know, 5, 0, how much would the radius be? 5, and so on, okay? We're going to leave it at 1 just to make it simple. Okay? Now, how many degrees is the angle that I've created here? Right here, standard position, terminal side, initial side, all here, 0 degree angle right here. Okay? So if I have a coordinate like this, 1, 0, 5, 0, I have a 0 degree angle. So now, can I find sine of that angle? Sine of 0? Sine of 0, we said sine was always going to be y over r, right? What's the y coordinate of this? What's the y coordinate of that point? 0. And what's the radius, did we say? 1. So sine of 0 ends up as 0. Okay? What about the cosine of 0? Cosine of 0, we said that was x over r. What was the x coordinate here? 1 over 1. Cosine of 0 is 1. Are you guys with me? What's the tangent of 0 then? It's y over x. It would be 0 over 1, 0. Okay, now, can we do cosecant of 0? Undefined. Thank you. Can we do secant of 0? 1. And what about cotangent of 0? undefined. Okay, now let's do the one for 90 degrees. Can anybody give me a sample coordinate for this point? Give me a sample coordinate for that point. Somebody, anybody? 0, 1 would work. 0, 1. What's r then? 1. Okay, so now quickly let's do sine of 90, cosine of 90, and tangent of 90. So quickly, what's sine of 90? 1, 0, 1, 0. I want you guys to be sure. 1, thank you. Good job. Okay? What's cosine of 90? 0. What's tangent of 90? Ooh, I'm way undefined, right? It's y over x, so it's undefined, right? And now, how could we do the other ones? Just the reciprocal, right? So cosecant is going to be 1, secant is going to be undefined, and what's tangent of 90 going to be? Cotangent of 90, yes, 0. Okay? And similarly, you could do the same thing for pi or 270. What will be a sample coordinate here? -1 or 0, right? So what's the cosine of 180? I have a -1. Anybody want to second that? Cosine of 180, x over r, -1 over 1, -1. R, right, because our coordinates, we're choosing our coordinates, right, to be like 1, r is going to be 1. So if you choose the coordinate to be like -5, 0, r is still going to be 5. So it's, right. Okay, it's going to be, and then, so like here, suppose you chose 0, -6. What's the radius going to be? The radius here? Okay. 6. The radius is a distance, so it's always going to be positive. I see. You see? Yeah. Yeah, yes. So 7 over 2, right? Okay, so let's do this one. Cotangent of 7 pi over 2. Where is that? Cotangent of 7 pi over 2. How much is that? 7 pi over 2, that's like 7 over 2 pi, right? It's 3.5 pi. So here, it's going to be 2 pi. So is it going to be top or bottom? It's going to be bottom. Here, okay. 2 pi, 3 pi, another half pi right here. Okay? Right. But it's a quarter. Okay, so 2 pi, full circle, 3 pi, and a half pi. Okay, so now, so we're here. A sample coordinate over there would be like 0, -1. So now if I want the cotangent, right, that's x over y, 0 over -1, 0. All right? No. If you were to do like 0, -5, it would still be the same. Yeah, once we get to the unit circle, it's all ones. Okay, 450. Where is 450? Right, left, up, or down? It's the same as 90 here. So sample coordinate 0, 1. I want tangent y over x undefined. Please note that if you put 1 over 0, there is no credit for that because I don't know that you know that that's undefined. Okay? Thanks. Okay, reference angle. A reference angle is used to evaluate functions, trig functions of any angle. How do we find the reference angle? It is the acute angle which lies between the terminal side and the x-axis. but it's got to be the nearest x-axis. So take a look here. Suppose you have an angle of like, oh, I don't know, 50 degrees, right? The terminal side and the nearest x-axis, that's this one, that's your reference angle. Now, suppose you have an angle of 160 degrees. Now, where is your reference angle? It's between the terminal side and the nearest x-axis. So theta prime is 20 degrees. Okay, yes. Again, anything in the right, anything in the first quadrant, it's just going to be that same angle. Okay? Now, for which one? For the 50? For 50, it's 50. Your reference angle is only allowed to be acute. So if this is the terminal side, it's got to be between the terminal side and I always say the nearest x-axis. What do I mean? From the terminal side, I could go this way to the x-axis or to the right to the x-axis. The closest distance is what I take, right? No, the x-axis. You only go to the x-axis. So let's take this one here. So suppose you have an angle of, I don't know, 210 degrees here. Okay? Your reference angle is between the terminal side and the nearest x-axis. So what is the balance there? Well, it was 180 until here. You had to go 30 more for this one, so the reference angle is 30 degrees. Okay? Now, the books always give you this complicated looking thing. Guess what I do with those? Cross it out, throw it away, don't look at it. I don't want to see you memorizing it. All right? We reason things out. So, take a look at this one. Suppose I have an angle of 310 degrees. The reference angle is the balance between the terminal side and the nearest x-axis. So it's 310 degrees. How much more do I have to go to make it a full circle? 50. So that's the reference angle. Never, ever, ever do this like theta minus, I don't even know what that is. Okay? All right? So, yes. Theta prime. That's reference angle. Yeah. Okay, so take a look here. Negative 150. Negative 150 looks like this. Okay? Where's my reference angle? Right here. How much is it? 30 degrees. So the reference angle is always positive and acute. Positive and acute. Okay. 3 pi over 4. Okay. 3 pi over 4. So this is the same as 3/4 pi. Okay? Here we go. We start here. Up until this point, that's half a pi. I'm going to go 3/4 of the pi. So right there. That's 3/4 of the pi. How much more do I have left over for the full pi? 1/4. So theta prime is 1/4. Now, it turns out in radian, reference angle is even easier to figure out than in degrees. Because if you have an angle in radian, all you do is pi over this number, and that's your reference angle. So if it's 11 pi over 7 or 11 pi over 6, what's the reference angle? Pi over 6. Okay? All right. Now, we use all this to figure out the trig functions of any angle. All right. 3 steps. Find the reference angle. Find the value for the reference angle. And then use the quadrant to determine the SIGN sign. Okay? If I ruled the world, I would make different words, different sounding words for SIGN and SINE because it's always confusing. Find the sign. No, find the SIGN sign. Okay, so we find the sign of the function using this mnemonic. Have you guys have heard this before? Yes? All students take calculus. So, all students take calculus. It doesn't have to be a true statement. It just has to work for math, okay? This tells you which of the functions are positive in each of the quadrants. Here, all of them are positive. Here, only sine is positive, and its buddy, the cosecant. Everything else is negative. Here, only the tangent is positive, and its buddy, the cotangent. And here, the cosine and its buddy, the secant, right? Okay. Okay, so here we go. This is the big idea. First, we need to find cosine of 120. So first, here, find the reference angle, okay? What's the reference angle of 120 degrees? Yes, 60 degrees. So theta prime is 60 degrees. That's step one. Step two, evaluate the trig function for the reference angle. Cosine of 60, how much is cosine of 60? Okay, so this is what we're gonna work on. Okay, so yes. So yesterday we were doing these triangles. We're gonna do them for like 20 more minutes, 10 more minutes. So 30, 60, 90, 1, root 3, and 2. Cosine of 60 is 1/2. What quadrant is 120 in? 2. Cosine is negative there. So our final answer is negative 1/2. Theta prime is reference angle. No, it's the reference angle. So basically like 120 would have been here, and the balance, that's that reference angle that we're finding. Yes?
When we use the triangle to determine to do the stuff we were supposed to memorize last year, what number do you use to sum it in?
If you have it memorized, let's use that.
So if you use cosine,
yeah.
like the test homework, and then you don't want us to just write it down.
Yeah, in a little bit, I'm going to show you how to do it on the unit circle, and then we won't need this anymore.
So for the test, if the quiz tomorrow, you should do it like this.
Do you have it memorized? Okay, so sine of 4 pi over 3, what's the reference angle? Pi over 3. Okay, so what's sine of pi over 3? Right? Sine of pi over 3 is root 3 over 2. Do you guys remember that from algebra 2? Oh. Root 3 over 2. And now, what quadrant is 4 pi over 3 in? Okay, so it's one of those. Okay, so here's how we do it. 4 pi over 3 is 4/3 pi. This is 1 1/3 pi. This is the only time I use mixed numbers. 1 1/3 pi. 1 pi and another 1/3 pi is in the third quadrant. And over there, sine is negative, so we get negative root 3 over 2. What's the secant of 15 pi over 4? Hang on. Reference angle. Reference angle. Pi over 4. What quadrant is this in? Okay, so what's 15 pi over 4? It's 3 and 3 pi over 4, so it's 3 3/4 pi. So 2 pi, 3 pi, 3/4 pi, that's in quadrant 4. Right? So would secant, which is the buddy of the cosine, be positive or negative there? Positive. Okay. Secant of pi over 4 is root 2, right? We have 1 over root 2, 1 over root 2, so it's root 2. Okay. We'll do more. By the time this lesson is done. Yes. Because in the fourth quadrant, cosine and secant are positive.
So the root 3 over 2.
And sine is greater than 0. So we have secant, and we have that sine is greater than 0. All right, we're given that information for a reason. Here's why we're given that information. The fact that we're told that sine is positive, that tells us which two quadrants we could work in. So look, in which of the quadrants is sine positive? The first and the second. Now, what about secant? Secant is like cosine, and we're given a positive value for that, right? So secant is positive in the first and the fourth quadrant. The quadrant where both of them show up is where all of our answers are going to lie. So in this case, all our answers are going to lie in quadrant 1. Now, we are told that the secant of this angle is root 21 over 3. Now, secant is hypotenuse over adjacent, right? So if it's root 21 over 3, that means the hypotenuse is root 21. And the adjacent is 3. Okay? All right. That means we're missing that side x, but we can find that side x. Because x squared plus 3 squared is 21. Okay? So x squared is equal to 12. X is root 12, which is 2 root 3. Okay, now, once I have all three of these, can I find the other trig functions? Yes. So, sine of theta is 2 root 3 over root 21. Okay, now I know I said we don't have to rationalize denominators, but you see how in this case you have a root 3 and a root 21, and those can cancel. So it could be 2. We can combine things in a root. Root 3 over 21. Right? So that would be 2 times root 1 over 7. Which is the same as 2 over root 7. Okay, and you can leave it that way. All right, let me quickly do the other ones. So cosine of theta is 3 over root 21. Tangent of theta is 2 root 3 over 3. Cosecant of theta, root 7 over 2. Secant we're already given. Cotangent of theta, 3 over 2 root 3. Okay? We'll stop here, and you don't have to do the homework for tomorrow. Just study for the quiz for tomorrow.